Hi and welcome to a very special video. This channel has now over 10,000 subscribers and that is really huge. So thank you all for subscribing to this channel and supporting me in my work of creating video tutorials for Swift. As a thank you, I'd like to give you today a very special tutorial, but also access to a very cool new app which is called Core Animator. This app really allows you to create stunning stuff and integrate them into your apps. So let me first show you what we're going to create in this tutorial, and then let me give you a quick overview about the Core Animator app. So let's have a look at Swift Road, or as we are going to call it, Swifty Road. I'm just going to play it for a second so that you can get the idea of what we're going to create. So there we go. This is a really cool app where you drive a car from left to right and you have these little opponents which are coming from the top edge of the screen, and you've seen some nice animations like, let me just give you a quick look at them again. Here are some clouds coming from the yellow car. We have the moving road, and of course we have a nice explosion once we hit the other car. And some of these things are sometimes really hard to create. You would have to create PNG sequences or use Core Animation for that kind of stuff. And this gets sometimes really hard, and you have to write tons of code to achieve these looks. And this Core Animator app, which I'm going to show you now, makes all of that very easy. So once you go to their website, coreanimator.com, you can see an overview over the features. You can download a free trial or go to the App Store and download it. As you can see, costs about $80, which is absolutely worth it. So every cent you invest in this app is saved time for you. So let's just have a quick look. There are some tutorials, and as you can see, some games of big studios already used this Core Animator app. And you can create keyframes, move characters, create spinning wheels, create focus points, instructional stuff, full scenes, and so on. And as you've seen in our little app, you can do very easy animations like the driving road, or you can create some clouds or whatever. So this is really huge because you can create animations without having to write a single line of code. And since I want to thank you for over 10,000 subscribers, I have asked the guys at Core Animator to supply me with some promo codes for their app. And as it happens, I've got 5 promo codes which you can win if you write into the comments why you would like to use Core Animator. So let's get started. I'm going to show you now how to create animations using Core Animator, and you can get started by downloading the free trial version, and you can do all the stuff I do now with the full version, except for exporting the files. So in case you want to go with the trial version, I have included all the exported animations into the tutorial files, which you can find below this video. So let me get started by opening up Core Animator, where you can see some introduction videos, walk cycle video, a full game video, UI spinner video. So they give you a huge amount of documentation and help to get started with this Core Animator app. So we are going to create a little and very simple animation using a steering wheel, which will not be part of our app, but I want to show you how you create animations using Core Animator and how to export them and how to use them within Xcode. So I have created a new I've created a new project, and as you can see here, this is a pretty simple user interface, and I have already prepared a little steering wheel here, which is an Add2X version, and I'm simply going to drag this steering wheel into the Elements pane here and release my mouse, and as you can see here, we now have a steering wheel here in our user interface. And once I click that, you can see that we have different options for the position, for the scale, for rotation, for the opacity, and actually all these options are also animatable. So what we want to do now is creating an animation where this steering wheel turns to the left and where it turns to the right, and we want to integrate that into our code. So we will simply drag this to the upper left corner here of our scene, of our canvas, and then resize that so that we have a nice looking steering wheel here. We're going to add an animation then, and this is really simple. You simply click on this little plus here to add an animation, and now you can title these this animation, and I'm going to name it Turn Left for starters. And I want to this is the timeline which we are going to use to animate. So as you can see, we have here 10 seconds, 20 seconds, 30 seconds, and so on. And by using this slider, I can zoom in so that we can, for example, have only 0.5 seconds for a turn of our wheel. And to create an animation, I simply select a time like this 0.5 seconds here and select my steering wheel, and now I want to rotate this wheel to the left. So I rotate, let me say something about, well, actually 360 degrees, minus 360. And as you can see now, once I scrub through this timeline, this steering wheel already turns, and I can influence this animation by clicking on the tween that is created between two keyframes. And this is actually, you can see a keyframe here because it's the standard canvas keyframe, which is the position of the steering wheel as we have positioned it on the canvas. So as you can see now, I have a tween here. And I can, for example, tell it to overshoot, which results in an animation like this. You can simply press enter to start the animation. As you've seen, it overshoots a little. And if you want to keep this animation in a loop, you simply have to click once on this infinity symbol here, and it loops. As you can see, once I press enter, it loops and loops and loops and loops. And this is really cool. And not only can you create a loop, but you can also, once you click it again, you can create an auto reverse. So it turns to the left and turns to the right. But this is not what we want to do here. We actually only want to turn it to the left. And we also do not want an overshoot. I will simply select linear here, but to show you how to work with these keyframes, I could, for example, also put a keyframe here and create this keyframe here by clicking here and then reduce the opacity, for example. But I want to start this opacity reduction here at 0.5 seconds. So I also click here again, press the opacity button and put it to 100, and as you can see now the animation starts here at 0.5 seconds. But this is actually not what we wanted to do. We just wanted to turn a wheel. So we turned it to the left already, and now we can actually duplicate this animation. Click with a right click and duplicate, and we can then say turn right. And we have the same animation here, but the only thing we need to change actually is the rotation of our steering wheel. And instead of minus 360 degrees, we simply say 360 degrees. And as you can see now, we turn to the right. And now let me save this project simply on the desktop, and let's call it steering wheel. And then I click on export. And this gives me an export window where you can preview your animations again. So here we have the turn left animation, here we have the turn right animation. You can select for which platform you actually want to export this this project, from Mac or iOS, or if you want to have your code in Objective-C or in Swift. And of course, what's also pretty nice is that you can select if you want the animation to be clipped or unbounded. Which is nice. And if I zoom in a little here, you can also see what this does. And you're maybe familiar with the clips to subview property of Xcode. And this actually allows you to display images within this canvas, but also beyond the canvas. And once you click on clip, everything that goes beyond the canvas will be, well, clipped. And we don't want that. We simply want to use the unbounded property here, and we select export and save it to a new folder. Let me call it steering wheel, and create and export all of that stuff. And as you can see, once I open that, we got an images folder with a 1x and a 2x version, although I have only imported a 2x version. The 1x version was generated automatically, and we get a steering wheel view .swift file, which we can now use in Xcode. So let's fire up Xcode and create a new project. Let me just call this Core Animator example, and create that. And now that we have our project ready, let me bring our new folder steering wheel into our project and import all that files. And I make sure that I have selected copy items if needed. And I also want to add all this stuff to our target Core Animator example. And I finish, and there it is. There is our Swift class and the images, which we do not have to import into the image assets folder, since all the images are managed by our steering wheel view Swift class. And as you've seen, this is a view, so we can actually use a standard view in our storyboard. And I'm going to bring a view to the storyboard here and make this a little smaller. I'm just positioning it in the center somewhere, which is quite difficult since it's white. But what I want to do now is selecting the custom class in the identity inspector here and select our steering wheel view as a custom class. And now what happens is that we can really see our animation view that was created by Core Animator. And the reason for that is that the file is configured as IB designable. The class is configured as IB designable, which results in the our view to display its contents in Interface Builder, and this is really helpful. And now the standard adjustment for each view is when you create it, it's the content mode is scale to fill, which is not always what you want. So we will select aspect fit to give it a correct size and the correct feeling, which we wanted to achieve, and make it a little smaller, and now positioning it exactly in the center of our view controller. And to keep it there also on every device, we want to create some layout constraints. I simply click and drag to the super view and tell it to be centered in horizontally in the container and vertically in the container. And also I want to give it a fixed size, so I simply drag something like this within our frame and fix the width and height, and I can actually select both of these properties by holding the shift key pressed, and now pressing enter results in the creation of those layout constraints. Well, all right, now we have our steering wheel view positioned correctly in our view controller, and now all we need to do is create an outlet of this steering wheel. So let me just create an outlet and call it wheel, and there it is. And let me also create two buttons, one here, and let me call that left, and this one right, and also create some layout constraints to the bottom and to the left, leading space, and here trailing space and also bottom space. That should do it. And then let's also bring up the interface, the assistant editor here, and create two actions. One action, which we will call turn left, and another action, which we will call turn right. Now we can use this this outlet to start our animation. Just let me give this a quick look and run the application in the simulator for a second. And as you can see, there is our steering wheel. And now let's add actually 2 lines of code using the wheel and typing add turn left animation. And in this case, wheel add turn right animation. And now once we run the app again, what will happen is that once we click on left, you can see our wheel turns to the left, and once we click right, it turns to the right. And all we needed to do in code was actually adding those two lines, and this is really amazing. I can't imagine how much time this is going to save me, and I hope this is going to save you lots of time. And this is actually what was created by Core Animator, and this is huge. So this is what you would have to do when creating this animation by yourself. So now it's actually time that we have a look into the game that we are going to create, and you're going to be amazed how little code we actually need to write to achieve a nice looking game. So let's get right started. Let's first have a look at the files that you're going to get, which is all stored in the game files folder. And as you can see, you get the car, of course, which is not animated, but you also get the enemy car, the explosion, and the road as Core Animator files. And this is what we are going to have a look at now. So let's start with the road, which is really, really simple, actually. This is an PNG image of a road, and once I click on export, you can see the animation, which is looped, and which is simply always brought back to where it starts, and the graphic is created in a way so that the loop is seamlessly, so that we actually in the game see it as a continuous road that always drives and drives and drives and drives. So this is the first one, which you will get. The second one is the enemy car, which actually only has a pollute animation. So once you add the pollute animation, there are these tiny clouds that come from the car, and as you can see, there's only this is pretty straightforward, actually. There is some movement here and a little opacity change, so this is also looped and looks like a car polluting our environment. Well, all right, let's also have a look at the explosion, which I borrowed from an example project from Core Animator, which you can find in their tutorial section. They also created a nice game where you can shoot ducks, and this explosion looks like this. And we are going to use that explosion for our car once it hits the enemy car. So you will also get some sound files like a boom, the car background sound, yep, the car background sound, some music, and a success sound, which we are going to import later. Well, and there's of course the steering wheel, so that you can experiment a little. Well, let's fire up Xcode again and create a file. Let's call this Swifty road, for example, and create that on the desktop. And the first thing we want to do actually is using our road. So we open the game files folder, look for the drive animation folder, which contains the road view and the road itself as images. And we will simply drag and drop this folder to our Xcode project and select copy items if needed and add to targets, Swifty road, and finish. And now I will make my window a little bigger and bring up my storyboard. And the first thing we want to do actually is add a view, just like we did in the example before. So I type in UI view, bring that view to my storyboard and center it. And in this case, we also create some constraints. So I drag and drop, I click and drag to the super view and select leading space, trailing space, top space, bottom space. And now I'm going to select the road view as a custom class. And since it's IB designable, we are going to see the road view in a second. And as you can see, we now have our image a little distorted, so we will change the content mode of our road view from scale to fill to aspect fill, which will give us exactly the look we want. And then we will also directly create a outlet for our road, which we'll simply call road. And once since we are here, we can also say road dot add drive animation. And now we can run this application for the first time and actually see our road driving. And that's it. And that's pretty simple. And as you can see, since this is a loop, we can always drive and drive and drive and drive. And that's really nice already. So the next thing we want to do is create our initial values for our game. So what we do is closing the assistant editor and bring up our viewcontroller.swift file, and the first thing we want to do is create a init game function. So this has no parameters, simply init game. And what we want to do is create our player. And our player, actually we can create a property for the player. So let's say var player, and this is going to be a UI image view. Since we simply want to use this player as an object that can be moved left and right, we don't need animations for that. And we will simply create and initialize this image view here in init game. So let's say UI image view, and we want to init this with an image using the UI image initializer with a name. And the name of our image is car. And that means we also have to import our car to the image assets, where in this case we want to do that since it's not part of a Core Animator project. And we'll simply drag and drop my car into the image assets folder. And that's it. Now we will give this car some initial values like a frame. Let's say player.frame equals cgrect make, and we will for the start give it initial values of 0, 0 for the x and y coordinates, and a fixed size of 60 and 91, which I've discovered is a good size for our car. And now we can calculate actually its y origin, which is going to be player.frame.origin.y, which is actually this our view's height, so self.view, and its bounds and its height, and we will subtract the player.frame.size.height and an additional 10 pixels so that it's that it has a nice margin from the nice distance from the bottom frame of the screen. And now let's center the player. So center X. Come on, X. It should be a small x. Well, okay. And we will simply use cgrect get mid-x of self.view, self.view.bounds. And now we can simply say self.view insert subview player above the road. And once we run that, we should be able to see our car. But of course, in order to see it, we should also call the init game function within view.load. So here is the init game, and now let's build and run that again. And then we should see our car at a pretty nice position in the center of our road. And now actually what we want to do is add a gesture recognizer that lets the car move from left to right or right to left once you click here on either side of the whole screen. So in order to do that, what we want to do is create a new gesture recognizer property. So let me zoom in a little, and now we'll create the car movement gesture recognizer, which in this case is going to be a UI long press gesture recognizer, and we are going to initialize that here in our init game function by simply saying car movement gesture recognizer and then UI long press gesture recognizer. We will give this a target, which is self, and the action that we want to perform is going to be player pressed, something like that, and we use the colon to specify that there's going to be a parameter, and we will set now the minimum press duration to 0.001 so that we can get a direct response. And then we will simply add this gesture recognizer to our road and say add gesture recognizer car movement gesture recognizer. All right, and now what we want to do is having a look at the function that we now need to create, which is player press. So let me just add this function here, which is going to be player press, or I'm simply going to copy that, player pressed, and we will give this the recognizer as a parameter, and this is a UI long press gesture recognizer. All right, so now that we have this method in place, what we can do is trying to figure out how to move this car. Since we are not within SpriteKit, we have to find a way to call something that many times so that we can actually animate things also without using UI view animations in that case. So what we need to do is actually a timer, and we will create the timer here at the top. So let me create a animation timer, which is an NS timer. All right, so here we go. And this timer is going to be used, so let's say animation timer equals, and then we use NS timer and say schedule timer with interval and the long list of parameters. So we can now specify a time interval, a function, the target, of course, and then as a selector we can add the function that we want to happen every time the timer calls it. So what we want to do actually is set the time interval, and it's time interval, to 0.005 seconds, so that we have a smooth animation later, and the target is self, and the selector that we want to call is move car colon, but of course we have to implement that function first. And there is this great user info parameter which allows us to give our function some initial values, and we will use this user info to give our move car function an info about the direction we want our car to move to. So let's first of all set this to right, and if we set this to true, this timer is called until we invalidate it. So now all we have to do is decide in which case we want to move right and in which case we want to move left. And therefore we will simply use an if statement and use the recognizer state to discover when actually we should perform an animation, and the case is that we should do that when the gesture recognizer began recognizing a long press. So if the recognizer and its state are equal to UI gesture recognizer state.begin, what we then want to do is we want to check where we actually touch. So we will get a variable which we'll call touch point, And this is going to get the recognizer.location in view. And the view that we want to check is the road. So now we can simply ask again with an if statement, if the touch point .x is greater than cg_rect get mid_x of our roads frame. So in this case, we are on the right side. Then we can actually call our timer and give it the user info of right, so that we move to the right. And else, we will call the same function, but this time we tell it we want to drive to the left. And that's it, actually. And since we also need to find out when we have to invalidate the timer, and this is of course when we release our finger from the screen. So we have to change something here. So we say if recognizer.state equals UI gesture recognizer state.ended. What we want to do then is to check if there is already an animation timer. So if this is not equal to nil, then we want to invalidate and thereby stop the timer. So here actually we have to use an else if statement instead of an if. Else if and that's it. Here we go. And now all we need to do is implement the move car function. So let's also do that. Function move car, and the parameter that we will give this is actually a timer object, so ns timer. And then we can create a direction. So if we have to check if, since this is going to be optional, we have to check if there is a direction available. So if a constant direction exists, and we will use the user info as a string and unwrap this. So if this works, what we want to do is we want to get the player's current frame. So we'll get the player frame by simply saying player.frame. And let me give us some space here. And if now the direction is equal to right, then what we want to do is move the player to the right. So let's say player.origin player frame .origin .x plus equals 2. So we will move that 2 pixels to the right, and else what we want to do is move it playerFrame.origin.x. We want to move it to the left, so minus equals 2. And then all we need to do is getting our player again and set its frame to the player frame. And here we go. Now we can actually give this a go and try our app so far. And here's our car, and we click to the left and to the right. But as you can see, our car still can disappear from the screen. So let's add some borders here at the top. And for simplicity's sake, I will just add some borders in order for it to look good on the iPhone 6 screen. But you can, of course, use some detection techniques to detect the current device and then get the proper borders yourself. But to keep this simple here, we will simply use the iPhone 6 screen. So there's a left border, and we'll set this to 55 pixels, and there is a right border, which is going to be 230 something. All right, and now what we want to do is go back to our move car method, and now we can check within this if statement here if the player frame.origin.x is smaller or less than the right border, which we need to cast to a CG float in that case, CG float. Then, only then, do we want to move it even further to the right. And the same thing here if the player frame.origin.x, and in this case is greater than CG float the left border, then we want to move it to the left. And once we run that again, you can see that once I click to the left, the car can't go beyond this border here, and this is a little too less, so let's say 200. Well, let's try 50 and see where that goes. All right, 250 is good. So these are our two borders, and we can only move our car within those two borders. So we have already created now the game controller for our player car. Now what we also need to do is actually add enemy cars, and therefore we will create a specific function. So let's just add that below the init game function. So let's say add enemy, and we don't need any parameters here. So first of all, what we want to do is create a random car frame, since the cars should come from random X position, so that you are not prepared for where to look in the game. So let's create a random enemy frame. So var random enemy frame. Let's create a rect for that, cg rect make. We will add 0 for X, and the minus position is actually, since the enemy car has the same size as the player, we will simply say minus player.frame.size.height, and the width is going to be player.frame.size.width, and the height player frame size height. All right, now as you've seen, we don't have a X position yet. This is still 0, so what we need to do is create a random X position, which is going to be between the left border and, let's say, random and modulo right border, which will give us a random X value between our left border and our right border. And now we can simply add this to our random enemy frame, and its origin and its X value is going to be random X. But we of course have to cast that to a CG float first, since this is an integer, which we return here. And then we can actually begin and adding some pollution to our enemy. We will first have to create it though. Let's do that here directly below our player. And this is going to be just another property, which is going to be enemy, and this is going to be an enemy view, which we have to import first. So let's go back to our game files, and there we have the enemy animation, and we'll simply drag and drop this enemy animation to our project. Make sure copy files items if needed, and add to targets Swifty road is selected. And there we go, there's our enemy animation, and it contains an enemy car view. So there is our enemy car view. And once we have created this enemy car view here as a property, we can then initialize it here in our add enemy function, and we'll do that by saying enemy and then enemy car view, and we will simply initialize that with our random enemy frame. And here we go. And now we can add our pollution animation. So we'll simply say add pollute animation, and this will pollute the environment by simply saying stating this line. We add the animation that we have created in Core Animator. And now we can actually insert our enemy to our screen by saying self.view insert subview enemy above our road. And actually that's it. And all we need to do now is move our enemy to the bottom, and therefore we can actually use a UI view animation. So let's say animate with UI view, animate with the duration, and we also need options. And this looks good, so we'll use this method call. The duration is going to be, let's say, 5 for the start and delay 0. Options is going to be UI view, animation options, and we will use the linear curve so that there is no ease in or ease out. And then we need the animation, and we need also the completion block later. So let's also implement it here with success and a bool, and that looks good. Remove the code here. And actually all we want to do now is change the position of our enemy car by saying self.enemy.frame.origin.y is going to be self view bounce height, and let's add the self enemy frame height so that it just goes off the screen. And once we did that, once we have once our enemy is at the bottom, we want our enemy to be removed from super view. And also what we want is to create a new enemy, so we will simply call our add enemy function again. And now let's just try that and see what happens. Okay, we also need to add the add enemy function here to our init game. So once we did that, we should be able to see an enemy, and there we go, and you can see there is already the pollution animation running, and we have a car here, and now is a car here, and we could actually already play the game, but we now have, of course, to implement the hit test functionality so that we can detect when those two cars collide. And in order to do that, we will again use a timer which constantly checks if there is a collision between those two cars. So let's add another timer here. At the beginning of our file, this is going to be a property, and we will call this update timer. Also, again, a timer. And we will initialize that in the init game function just below the add enemy call. So let's say update timer equals ns timer schedule timer with time interval. In this case, our time interval is going to be 0.05 seconds, and the target is self, and the function that we are going to call is going to be update. We don't need a user info here, but we also want to repeat that, and I will add a column here in case we could need some parameters here. So having the timer initialized and moving forward, we're now going to implement the update function. So let's move down a little, maybe below move car, and add a function update. Give this a parameter, which is going to be a timer, ns timer. And what we want to do now is, first of all, perform our hit test. And this needs to be a capital T here. Then we have no error anymore. And let me give us some space here. And to actually perform a hit test, we can use a very simple core graphics function, which is called cg rect intersects rect, and then we can simply specify two rects and check if they collide. And since our enemy car is in a UI view animation, we can't use the just the frame of the enemy. We need to compare the presentation layers frame. So what we want to do is we will use our player and its layer and its presentation layer and ask for the frame, and we do the same thing with our enemy and its layer and its presentation layer and its frame. And if those two rects intersect, then what we want to do is actually end the game. So let's call an end game function here, and let's implement this function just below our update function, which is end game. And what we want to do here is, first of all, remove all animations from our enemy. So also the UI view animation. So what we need to do is, again, access the layer and remove all animations. Then what we also want to do is invalidate our update timer. So let's say timer.invalidate. And we also now need to let our both of our cars explode. So in order to do that, we need to import our explosion. So again, let's open the game files, search for the explosion folder and import that to our project and add it to our targets and so on. And now we have our explosion view here, and we will create that right there in our endgame function. So let's create an explosion constant, explosion, which is going to be an explosion view. Come on, explosion view, and we will initialize it with a frame. So let's say CG rect make, and we will simply set it to 0, 0 and give it a size of 150 by 150 pixels. And now let's set the explosion's center to actually the, let's say, CG point make. And the X position is going to be the enemy center X. And for the Y, we will position it a little higher. So let's say enemy.center.y, and let's subtract 250 pixels. And now let's change the content mode. Explosion.content mode is going to be center. All right, now we can insert our explosion by saying self.view, insert subview explosion above our player. And then what we also need to do is remove our enemy. So let's say enemy remove from super view, and also let's remove our player from super view. And now we will say explosion, add explosion animation, and now we will use the completion block of our add explode animation, and we need to specify a bool here. So let's say success. Don't need to check it actually, but let's just specify it. And now we will create an alert view and say UI alert controller, a title, say game over, and ask the question you want to play again, question mark, UI alert, controller style is going to be alert. And now we will add two actions. First of all, alert.add action, UI alert action, and the title is no, action style is UI alert action style cancel. We don't need a handler here. And also alert add action, UI alert action, say sure here, UI alert action style is going to be default, and the handler needs an alert action, so UI alert action exclamation mark. And what we want to do here is actually nothing else but call the init game function again, which will do the rest for us, and then we can present our view controller alert. It should be animated and no completion block needed, and then we can also remove the explosion from super view. And now we can give this a try. So let's see what happens. So we drive around and there is a car and boom. But as you can see, there is still another car coming. So we have to improve this a little more. And the first thing we want to do is we want to create a bool that tells us if we are still playing. So let's create that bool here, var playing, and set this to false. And as soon as we have initialized the game, and actually before we have created our player, we can actually say that playing is now true. And playing isn't true anymore once the game has ended. So let's go down here, and after invalidating the timer, we can also say that playing is now false. And what we can do now is really simple. We can go back to our add enemy function, which is right here, and only perform all that stuff of add enemy while we are playing. So if playing, then we want to do that. So let's just cut this out and paste it here again. And now, as you can see, once we run our game again, and we have crashed with the yellow car, no more car is approaching from the top of our screen. So this is actually pretty cool. We have now a fully working game. We can play a game again, clicking sure. A new car appears. We have our yellow car. We can crash again with our nice animation going on here. And now we have to do some refinement and some improvements because the game is not really worth playing yet, since we have no points, we have no levels, and so on. And we're going to place a point counter and a level counter to the top here. But first of all, let's get rid of the status bar. And to do so, we need to go to our project and set the status bar style to hide status bar, or status bar style default, and hide the status bar. We can also deactivate landscape left and right because our game is only played in portrait. And what we want to do now is go to the info plist and right click it and open it as a source code. And we will then add two new keys here. The first one, so a key, is going to be UI status bar hidden. Close that key. This way. Key. And set this to true. And then another key, which is going to be UI view controller based status bar appearance. And we will also set this, in this case, to false. And here we go. That should deactivate our status bar. So let's have a look. There's no status bar anymore. And if you ask yourself how to get this also adjusted in the storyboard, what we can do here to get rid of the status bar in the storyboard is selecting the view controller and set the simulated metrics in the attributes inspector of status bar to none. This, however, will cause our auto layout constraint, actually it should, or it does sometimes. We have a road view, and once we have a look at the top space, as you can see here, there is this top space of the status bar that should not be there anymore. So we actually need to set this to 0 in order to get no auto layout constraint problem here. And once we run that again, you can see that it still works pretty nice without a status bar. So let me close the simulator. And what we want to do now is add another view to our view controller, which should not be part of the road view. So we'll simply drag that to another position and then make the adjustments here in the size inspector. And the width is okay at 600 here, but let's adjust the size to about 40, or let's say 50 pixels. No, 45 will be enough. And then let's add some constraints to it. So to the super view, which will get a leading space, a trailing space, a top space, and then we will set the height as fixed. And then we can add some labels here. So let's add a first label. Let's add that here. Call that points. And another label, which we will set to 0. Give it a little greater width, and then another label which we will call level, and another label which we will set to 1, and make this also a little bigger. All right, now we will set the layout constraints for these UI elements. So in this case, we can do it in relation to the view, to this super view here. So we have a leading space here, we have a top space here, which is enough for a label in that case. And we can then use the horizontal spacing here and add a top space here, and also fix the width of our points. And let's also make this a little bigger, make a trailing space, a top space, and a fixed width. And then we can add horizontal spacing and also here a top space, and this should do it for our user interface here. And as you can see, we still have a little problem here because we can't see the points yet, so we have to check that again. So no points. Let's remove the constraints here and just do it again. Points. Let's remove the constraint here. And let's just do it again. So for the view, we have a leading space, we have a top space. Points, leading space, top space. All right. Now let's check if we can see it. And there it is. And now let's, now we have a trailing space here. We have to remove that and make only a horizontal space here and give this a fixed width, and that should do it. All right, now that we have those UI elements, let's also create some outlets for them. So first of all, the points, let's call it points label, and create an outlet for the level label. Here we go. And then let's first of all implement a function that will add our points to this counter. So we'll also create a variable here, which will be a points variable, which we'll set to 0. And then actually every time we miss a car, so we don't crash with the car, we can count, we can add 1 to our points variable, and also update the label that is related to this, that should be related to this variable. So every time we have a success here in our add enemy function, every time an animation is completed, what we do before adding a new enemy is going to be add a point. And we also only want to do this if we are playing, so we will again add our playing bool here in if statement, and we ask if we are playing. Then what we want to do is we use self.points and add 1 to the points, and also what we want to do is using our points label and its text property and set this to the points variable. All right, so now let's also try that. And we need to add a self here since we are within a closure. So now once we miss 1 car, here we go, we add 1 to our points counter. Very good. So now that we have a points counter, what we also should do is increase the difficulty once playing. So actually a good way to increase the difficulty for our game here is to increase the speed of the yellow cars. And to do that, we will also again add some new variables here at the top. And let me also add a variable for our update rate. So let's add first of all the update rate here, which is going to be 0.05. We will simply, so that you can make some adjustments there. Then we will add a variable for the difficulty, which is 0.0. at the beginning. This value is going to increase with time. And then we have a variable for the game speed, which will set to 2.5 as an initial value, so that we can actually decrease. The game speed is actually corresponding with the animation duration. So what we can do here is directly telling it that this is an NS time interval, and what we want to set this to the game speed. So we had a value of 5.0 seconds at the moment, and now we have an initial value of 2.5 seconds, which will make the cars a little faster. And once we increase the difficulty, we will subtract half a second or 0.25 seconds from the game speed. So we have a points variable. We now also need a level variable, which we will set to 1. And once we start the game and we call the init game function, we need to reset all these values. So the update rate will always be the same, but the difficulty needs to be reset to 0. So difficulty is going to be 0.0, and the game speed is going to be reset to 2.5, and we also need to reset the level to 1 and the points to 0. And then we also need to update our level label and its text property to the level variable, and also we need to update the points label and its text and set this to the points variable. Come on. All right, now that we have reset all that stuff, we need to think about how we can actually use these values to increase the difficulty and how to switch levels. But first of all, let's also add the update rate here, so that we have update rate, and then you can simply change all the game values that will influence the game here at the top of our file using these properties. And to make our game more difficult, we'll go down to our update function, where we have already implemented our hit test between those two cars. So this is going to be a hit test. And what we also want to do here is a level update. And to do so, we will first of all have a look at our difficulty. So what we do is we check if the difficulty is less than 20. So this is a value that we can work with. And if it's not 20, so if it's less than 20, then what we can do is we can add difficulty plus equals update rate. So this is a counter actually that we use. We have an update rate of 0.05 seconds. So once this counter reaches 20, we want to do something else, and this is going to be we want to reset the difficulty to 0.0, and then if our game speed is still greater than 0.5 seconds, yes, then what we want to do is we want to go one level up, and we can also adjust that in our level label. So let's set the level label to its new string, which is going to be level. And what we need to do to increase the difficulty, and this is now the striking point, is decrease the game speed actually, or the time that we are going to need to move one yellow car from the top to the bottom. So we will simply subtract 0.5. And you can actually play with these values, because actually you can only have up to 5 levels if you subtract 0.5 here, but if you only subtract 0.25 seconds from the game speed, then you could have increasingly more levels, and the difficulty would increase more slowly. But let's keep it that way for now, and now let's give it a try. So here we go. I have to So I have to be good at this now in order for me to show you how this game works. So we are at 4 points. We are at 5 points, still level 1. And let's see, when we reach level 2. Now we reach level 2 and the cars are already faster. Can still handle it. Well, let's see what happens when we reach level 3. Then you should also see how much faster actually the car gets. So 16 points, 17 points. And now we have level 3. Luckily the cars are more on this side. Okay. It's really getting harder. But I think you're going to experience that for yourself once you play around with this game. So I should stop, but I can't. Oh, yeah. Alright, now we are at level 4 and now you can definitely see how much faster the cars get. And here we go. Now the game is over. I want to restart, sure, and as you can see, the points are reset to 0 and the level is back at 1. And now that we have all this game logic implemented, we can have some fun with sounds. So let's go ahead and import our sound files, which are provided in the sound folder. And I'm simply dragging them to our file. Let's say here. No, not within the within this folder. Let me put it here. Make sure Swifty Road or whatever you call our game is selected, and copy items if needed is also selected. And now let me just bring these into a new group. Let me call this sounds. And also let's put all of our animations, the explosion, the enemy and the drive animation, into a new group, and let's call that animations. And let's close that. And all right, now we have also one interesting file in our game files here, which is a sound manager, which I've adopted from one of the examples of a Core Animator example, which is quite useful. And I've already put all of the sound file names into it, and it's actually pretty straightforward. It is a class that will allow us to play or loop sounds without having to think about AV audio player and stuff, because we just want to play some sounds, right? And to work with this sound player, we simply have to create an object of it, and we will call it sound manager. It's going to be a class of sound manager, and we simply initialize that here, and this will actually help us to work with sounds. And first of all, we will add our music to the view.load method. So just below add drive animation, we'll call our sound manager with lowercase s and say start looping sound for K sound background music with a volume of 0.1. Then once we init the game, we want to get some ambient noise, which is going to be start looping the car sound. So K car sound car volume is going to be 0.1 here. Let's change that to 0.5 here. And what else have we got? We should have a sound once we have a point. So let's go to the add enemy here. And if we are playing and if we got a point, what we want to do is again use our sound manager and in this case play a sound, which is going to be K sound success. And what else? We need a sound when we have lost. So let's go to end game. And what we want to do here is first of all play the sound of our explosion. So sound manager play sound K sound boom. And we also want to remove the car ambient noise. So let's say sound manager dot stop looping sound K sound car. And now let's give that another look. So here we are, when we have a success, and also boom, and the ambient noise is deactivated. So actually this looks pretty good. So this is it actually. And now have a look at this. We have created an amazingly cool game, which is pretty simple of course, but look at the amount of code. This is just nothing. This is just nothing what we had to do to create a game, and with nice animations actually, and you could actually imagine to add even more animation to it, like something for the player car, or even more stuff for the enemy cars, or adding different enemy cars whatsoever, or adding an animation to make the movement look cooler, or an intro animation, or whatever. You can actually imagine how much easier this is going to make your life when you're working with animations. So again, Core Animator is really a huge leap forward in creating nice looking apps, and this is also going to help you to stand out in the App Store, which is increasingly difficult. So go ahead and have a look at the trial version, and if you like it, go and buy that software. It is again worth every cent you invest into it, because it gives you a lot of time in return. And don't forget that you can get a promo code so that you can get the application Core Animator for free if you write into the comments why you would like to use it. There are 5 promo codes available, and I will select 5 of you to receive that promo code completely randomly. Have fun creating this nice game, and let me know if you would like to see more Core Animator videos.